So we divided first. I forgot to turn on my. This is all I'm missing from the next video. So we divided both sides by 2, and now we are applying natural log. So we move this in front as a factor, but we establish now that natural log e is 1. So I don't have to write anything. How do I get t? What do I have to do to both sides?
Divide by 0.045.
That's it. Thank you very much. Let's plug it in. So I'm sharing my screen. So I have natural log 25 and divide by 0.045. So let's see. So 71.53 hours, approximately. 75.53 hours are needed for the area to become 50 millimeters squared. Final question here, when will the colony's area be double the original area? Double the original area. How do I determine that? What is double the original? The original was 2.
Times 2.
Exactly. So double means 4, right? So I have 4 equals 2 e to 0.045 t. I don't want you to have to memorize formulas. It's so easy. I have to clean it up again. So let's clean it up. What do I do?
Divide by 2.
Of course. 2 equals e2 all this. We just repeat with 2. So this is natural log 2. And this is 0.045 t. And from here I have the same thing, but natural log 2 in the numerator. So let's see what we get. See how long it takes to. So here's what I'm going to do. That's how lazy people deal with this. I'm kidding. And I just want to delete that, and that's it. So 15 hours, approximately 15.40 hours. Okay. I think we had enough. Is this okay? Is this okay?
Yes.
Yes.
Okay, so now let's talk about the derivatives of the exponential function. So in the next section, we talk about derivatives of exponential functions with base e only. And in the last section of this chapter, the same thing for natural log, the derivatives. Okay, so 2.2, derivatives of e to the x or e to a function of x. I think you're going to like this function because it's its own derivative. So if f of x e to the x equals e to the x, f prime equals e to the x. This is a nice function, friendly. No, I don't have to worry about its domain. I don't have to worry about anything. This is a cool function, unless it's a pandemic. And
Professor,
then it's
why
not.
does it equal pretty much the same thing?
Yes.
Like, wouldn't it change at all?
No.
No. Okay.
We can. It's a very good question. So allow me to. I love questions. So, okay. You don't have to just follow this. You don't have to write this piece. I'm not going to ask you. So, let's say, how do I get the derivative of this function? Well, I know it's a long process. I know it's not it's cumbersome. It's not friendly, but that's what it is. It's the limit as age approaches 0 from the difference quotient, which is e to the x plus h minus e to the x divided by h. That's how it was determined. So we want to know what is the derivative of this function. We don't know what it is. Okay. So we're going to do it like this. So then limit as age approaches 0. I will have to change this. We know that e to a times e to b is e to a plus b. But I can also go backwards. E to a plus b is e to a times e to b. Of course, I will factor. This is a factor. It does not depend on age. I can move it completely outside. It's a number. For the purpose of age approaches 0, it doesn't mean anything. And limit as age approaches 0 from e to age minus 1 over age. In this particular case, for this function, what I said before, it doesn't work. I cannot simplify all terms without age and then eventually simplify this. So for this function, this doesn't work. But let's look at this limit. And after that, we will draw a conclusion. So I will punch in y equals this function. I don't have age in the calculator, I have x. So I have to use x. But it's not the e to the x from the front. It's the limit of the function that we are looking at. So I have e to h, but I don't have age in the calculator, minus 1, close, and divide by h, which is x. So what I want is to evaluate this function left and right of 0. I cannot plug in 0. That's not possible. Why I cannot plug in 0? Anyone?
Because age cannot be 0?
Of course, because x is in the denominator and I get error, of course. But I can plug in numbers close to left and right. So, negative 0.0001. Let's see what happens. Let's see on the other side, 0.000001. So we know now that this limit is
One.
exactly. So therefore, the derivative of e to the x is e to the x. Okay. Now, the thing is, what if I don't have the power that is, so to be exact, the chain rule really is asking us to write x prime. But we don't. Why don't we write x prime here in the formula?
Is it because of e, like the natural
Because x prime is
0? 1. It's 1.
exactly. That's why we don't write it. But now let's see what happens if I have e to a function. As an example, e to 5x. This is not x. This is a function, 5x. So then I'll have to use e to the function times the function prime. So when I differentiate this, can anyone tell us the answer for the derivative? Anyone would like to give it a shot?
The top one was the example, right?
This is the formula. This is the example. This was a calculation because Ryan wanted to see how come, and he's right. And I don't like to give just recipes. Here, just memorize it. I don't. So he asked, but because I'm behind, I didn't want to show the rule. I mean, the steps. Because I'm not going to ask you to do that anyway. But he said, and he was right. Wait a minute. Just show me. What is this? Where do you come up with this? Where does it come from? So that's why I showed where it's coming from.
So would it be e to 5x equals 5x to 1? Or times, I'm sorry, times 5x.
It's prime. This is prime. This is not 1. This means this is the derivative symbol.
Is it times 5?
That's it. So this is 5e to 5x. Done.
So that second one we would do just like we were taking the regular derivative.
Oh, but everything is regular derivative. This is regular derivative. This is regular derivative. This is regular derivative. So when I
just kind of do
differentiate,
it without the stuff we just learned, like the stuff we knew before.
yes. So I have e to a function prime is e to a function times the inner function prime. So many of you, and that reminds me, on the test, for example, we had, I don't know, 2x plus 1 to negative 4 to differentiate. And many of you wrote negative 4 times 2x plus 1 to negative 5 without times the inner function prime. So we learn when we pay attention to and we write, we listen, and also compute. So please listen to what I say, because I know I sound like a broken record all the time. So negative 4, subtract 1 from the power, times the inner function prime. Okay, so I like to look at problems on page 210. You feel free to choose if you want to choose. So we're on page 210. I like to choose something like 13 first. So we have f of x equals e to negative x squared plus 8x. So this is an example that we just, similar to what we just did. So can anyone give us f prime? Anyone? It's okay if you're wrong, I'll help you.
Would it be e to the negative x squared plus 8x times negative 2x plus 8?
Brilliant. Thank you. That's all it is. Does everyone understand this? Any questions?
Yes.
Any questions here, please? Any questions?
That would be the final answer.
The
Correct?
final answer, I'm not asking you to do anything here, although to be exact for the next chapter, in chapter 3, I will ask you to make sure that you factor out negative 2, write x minus 4, e to negative x squared plus 8x. Because you'll see why this is important. But for this chapter, for this section, it's okay if you just leave it as is. Okay. Other examples. Now let's look at some product rule here. Okay, so something like 11. Still on 210. So f of x equals x squared minus 2x plus 2. Everything multiplied by e to the x. Now we have to realize what this is. This is function 1. And this is function 2. One other situation that I noticed that broke my heart, there was a function on the test, something like x plus 1 over, I don't remember, 2x minus 3. And someone differentiated and said this is 1 and this is 0, this is 2 and this is 0, and got 1/2. And you could have seen tears in my eyes, because this is the quotient rule. We can't do any of this. We can't invent anything. Okay, so this is the product rule. Remember, if you need to, write it on the side. It's 1 prime times 2 plus 1 times 2 prime. So then f prime of x equals Can anyone give us 1 prime? And I will write it here. And then times 2, which is e to the x.
2x minus 2.
Very good. Awesome. And then plus, I copy the first. And yes, luckily, this is the nice function when it comes to differentiation, but not, apparently not in real life. It's not that friendly. E to the x. Yes, I do have to factor out e to the x. And I have to write everything else, 2x minus 2 plus x squared minus 2x plus 2. And I have to clean it up. So x squared, these two go away, and these two go away. Fine. So this is x squared e to the x. Any questions? Yes?
Is this what we're supposed to upload for the day?
If you'd like, that's fine. Let's upload it. Do I have the upload there? Is it there? Because I had so much grading to do, I don't know if I checked.